Welcome to Spring LIB.
This is chapter 31, problem number 2 from the Smith Organic Chemistry textbook. And so in this problem, we're given 4 different monomers. What polymer would be formed from the polymerization reaction of each monomer. And so one way to sort of look at this problem and figure out what the answer would be to just draw like 3 of these monomer units in a row, and then erase one of the double bond lines in each and connect the molecules instead. And so I'll show you what I mean by that. So for the first one, okay, so first of all, remember that the notation for drawing polymers involves, starting and ending with squiggly line brackets to show that the polymer is continuing in either direction pretty much indefinitely. So here are these 2 chlorines, and then what's happening? Okay, and then we can put our double bond there, and obviously this has one too many bonds, this carbon, but that's all right because we're just using this to get started. So then we can do the same thing next to it, chlorine, chlorine, and then one more time, double bond, chlorine, chlorine. So there's our 3 monomers, and then we can actually go ahead and just show that this is also going to continue indefinitely in that direction. And so my advice, if you're struggling with these, is to sort of do it like this, where you draw several of the monomers in a row next to each other, and then just go ahead and erase one of the 2 double bonds from each of these, and then connect the carbons that you just erased double bonds from. So boom, boom. So there you go. That's how a portion of polymer made from the monomer that we're given in A would look. And this is a viable strategy for all 4 of these. So go ahead and look at B. So B is these styrene derivatives. So we can just go ahead and go like this. What is it? OCH3. OCH3. So again, if this is like something that you struggle with, just draw 3 in a row. So there's 2. We'll draw our 3rd one. Oof. So there's 3 of these in a row. And then, as I said, we can just go ahead and erase the double bonds. And then just connect these. And obviously, this isn't super pretty looking. You could clean this up and shorten the distance between these monomers in the polymer. But if this is something that you struggle with, it might be easier to draw it this way. So here, I'll go ahead and move these over somewhat, and move this one over somewhat. And then There we go. That looks a little nicer. And then again, as we did for A, we just show these continuing indefinitely with the squiggly brackets. And so that's how B looks. So then for C, the monomer that we're given is going to be this. So we can do that. And then following the same strategy that we used for A and B, just go ahead and get rid of the double bonds, and then connect the carbons that we just lost double bonds from. And then just show this again. Sorry, that's a messy looking bracket. It doesn't really matter. Right, and so show them, continuing off indefinitely. And then for D, so D is exactly the same as C. It's just instead of an OCH3, we have a CO2CH3. So we can, you could follow the strategy that I've been talking up, or you could just go ahead and draw them in. So CO2CH3, CO2CH3, CO2CH3. So if you do struggle drawing these vinyl-derived polymers, that is one easy way to do it. Just draw the monomers out in a row, erase the double bonds, and then connect those carbons. And that's the answer to chapter 31, problem number 2.